In this lesson, we're going to look at using slope-intercept form and how it's used in word problems. So for this lesson, we have a warm-up problem to get started with. Just reviewing, we're going to write the equation of the line in slope-intercept form. So slope-intercept form, if you'll recall, is y equals mx plus b, where m stands for your slope and b stands for your y-intercept, so where your line crosses the y-axis. And y and x stay the variables y and x. So what we need to pull from the graph that we have here is a slope and a y-intercept. So we can see that the line is crossing our y-axis at the point 0, 4, meaning the y-intercept is 4. It's crossing at 4. So our b is going to be 4. And next we need to find a slope. So we could find the slope two ways. You could count down and over, or you could use your slope formula, which means to subtract your y's and divide it by subtracting your x's, getting -7/9 as the slope. So if m is -7/9 and b is 4, then to fill into our slope-intercept form equation, we will get y equals -7/9 x plus 4. So that's just a quick review of slope-intercept form. And so today we're going to get into how slope-intercept form is useful. All right, let's see if this will click. There we go. Okay, so when you're looking at equations, or I'm sorry, word problems that use slope-intercept form, you're going to notice certain keywords in the word problem. So your slope is going to be represented by your rate at which something is changing. So always looking for your rate. The rate is going to be your slope. So for example, if in the word problem you're told that you're being charged $2 per hour, that's a rate. So 2 would be your slope. Or 5 books per day that you're reading, for example. 5 would be your slope because that is a rate. Now your y-intercept is going to come from usually a starting amount or something that you automatically get or automatically have before the rate is applied. So for example, maybe you've already saved $36. That 36 would be your y-intercept, or you've already read 20 books. That 20 would be your starting amount, and then you're maybe adding on to it or subtracting away from it, whatever your rate is. So let's look at a problem. Did I go too many? Okay. Suppose you already have $30 towards the cost of a pair of shoes. You plan to save $6 per day working for your parents. We want to write an equation for the total amount of money, y, that you will have x days from now. This second portion here tells you your units, that the money will be the y, and your x will be represented by number of days. So that gives you a hint about your units later on when we're graphing. But from the word problem, let's see if we can pull out our rate for the slope and our starting amount for the y-intercept. So at the beginning it says you already have $30. So that $30 is a starting amount, which means that that is going to be your y-intercept or your b. Later in the problem it says you plan to save $6 per day. That per day indicates a rate. We're saving $6 each day, so that's going to be constantly saved day after day, so that's our rate, meaning that 6 is our slope or our m. So filling in to y equals mx plus b, we found the slope to be 6 and the y-intercept to be 30. So we replace b and m to get y equals 6x plus 30. So that would be your equation for this problem. Now, if we wanted to quickly graph it to get an idea of how this is going to be helpful to us, I could set up my grid And I'm going to count on the y-axis by 5s. And if you're going to count by something more than 1, it's important to label. So my y-intercept is here at 30. Now on the x-axis, let's count. I'm going to count by, oops, what is that thing doing? Let's see. There we go. I'm going to count by 1s on the x just so it's not as concentrated. Okay, but so we're starting at the y-intercept. Remember, to graph from slope-intercept form, you always plot your y-intercept first and then count your slope out after that. So up 6 and then over 1 would put our next point there, then up 6 over 1 again, and we can start to track how much money we'll have over time. So remember that y was represented by our money and x was represented by days, I believe. Yep. So here you can see the days increasing 1, 2, 3, 4, 5, and so on. Here we can see the money increasing on the y. And so that can help us see after how many days we would have a certain amount of money. And we can project and graph and look to those other parts. Now you'll notice that I only plotted in quadrant 1. We do know that this is a line and it goes on forever though. So it would be acceptable for the equation to plot that line going in both directions and extending it onto forever. And in fact, that's what y equals 6x plus 30 represents, is this line going on in both directions. However, this portion of the line in the word problem doesn't actually make sense. If we think about this going into days on the x-axis, going into -1, -2, -3, that portion of our graph doesn't make sense because time always passes. We never measure or can measure a time negatively. So we're not going to have a negative amount of days. So going in the x-axis direction for this graph wouldn't make sense. And we also know if I'm looking at money, so down here at -$15, -$20, going negatively on the y-axis wouldn't make sense either because we're told in the problem that we already have $30. So there's no way, there's nothing saying that we're losing money, we're not going into any debt here, we're saving and adding on. So that's why I did not plot originally the graph into quadrants 2, 3, or 4 because it just doesn't make sense for our line to go into the negatives in this word problem. However, it's important to know this equation really does represent the line in both directions. But when we're dealing in word problems, we often, not always, but often focus on quadrant 1 because that makes most sense. All right, let's look at another one. You get a job and earn $9 per day. You already have $50 in your bank account. If you continue to save your money made, write an equation in slope-intercept form to model this situation. So we're looking for a rate and a starting amount. So here we're given $9 per day, and we already have $50. So the $9 per day is our slope because it's a rate, and our $50 is our y-intercept, our starting amount. So the equation would look like y equals 9x plus 50. In this situation, in this word problem, I did not give you, I'll talk about that in a moment. I did not give you the units for x and y like I did on the last problem. And so I want you to know that there is a way to tell what x and y stand for, and it actually comes from your slope. So let's take a look at our slope. If you remember, slope is your rise over your run, and the rise is the change in your y values, and the run is the change in your x values. So if I write this slope as a fraction, as 9 over 1, I can see that my y's are the 9 and my x's are the 1. And if I write now that slope as the rate with units, we're going to see it's $9 per day, per 1 day. So writing your slope out with units always is a foolproof method for figuring out what the units represent in the equation. So here I can see my y's are up top as dollars and my x's are on bottom as days. So if you did graph this equation, you would know that the x is your days in this problem and the y is your money because of the way the slope was written. Okay, so that's just a helpful tip. And this problem did come from the Rise Up, Run Out rap, if you'll remember that from our lesson a couple days ago. This was the lyrics for the rap, and we talked about that. So just showing how that word problem applied with slope-intercept form. Okay. All right, we have another one. Your dog is incredibly obese and you are changing his diet so that he can get back to a healthy weight. He currently weighs 106 pounds and will lose 2 pounds per week with the new diet he will be put on. Write an equation for the dog's current weight, y, that he will weigh x weeks from now. In this case, the dog is currently weighing 106 pounds. So that's your starting amount, your B. But he will lose 2 pounds per week. That is a rate. And the important word here is that he's losing the 2 pounds. So that actually is a negative 2 per week. So our equation, whoa, this is going a little crazy, should look like negative 2x plus 106. We're starting out at a positive amount, a weight of 106 pounds, but then we're going to lose 2 pounds per week. Now, in this situation, losing 2 pounds per week, if we graph this line out, we'd have something like this. And this is another situation where not all parts of the graph will make sense. We can chart his weight loss linearly for maybe a portion, but then that dog is going to reach a normal healthy weight, and we would stop this weight loss. And we also know it doesn't make sense to go in the other direction as well. If we wanted to take this further and figure out how much the dog will weigh after 6 weeks, well, our weeks is our x. So that means we put 6 in for x and simplify. So negative 12. So that means y, or his weight, would be 94 pounds after the 6 weeks on the diet. We have one last one, or maybe 2 more. A lifetime gym membership costs $45 for an initial registration fee. That's our starting amount. It costs $75 per month. That's our rate, so that's our M. So this equation would look like that. I don't know if that's the accurate equation for that membership. However, that could be a way to track how much you'll be spending. Oops, and I should not have M here. I should have X, sorry. How much you'll be spending over time. So you could input the number of months you're on the plan to figure out how much you would have spent on your membership by then. Did I miss the last one? Yeah. Okay, so it looks like that's all we have for this lesson. And in class, we'll have some whiteboard practice and Khan Academy. And we are done.